Alright, so got my data set of the top 2018 Spotify tracks, and we're going to be doing some analysis on that data set today. So, first I have just my data planned out, just what it looks like, and then I ran a correlation to see what attributes correlate with each other. And so, for the first question, energy will be my target variable in the data set because it's moderately higher correlation with the other attributes on how a song is received. Energy, when compared to attributes such as loudness, acousticness, and valence, have a relationship that seems to be pretty reasonable. Because when energy of a song increases, so does the other three, and that's why my variable will be energy to determine how long or how a song is going to do. Since most songs are rated higher on the top 2018 list. So for question two, for the predictor variable, I chose valence and acousticness because they are higher in energy. So the higher valence and acousticness a song has, the higher energy it has, and it's more likely to be perceived better by the people listening to that specific song. As seen in the scatter plot below, right here, where I compare loudness and energy, you can see there's a moderately high correlation here that's going on. And then finally, I compared acousticness and energy together, which gives us a correlation, but it is negative. So that does tell us a little bit about both those attributes. So for linear regression amongst the independent variables of loudness and energy, I performed a regression and found that the R-square was 0.537, which isn't great, but it's acceptable. And here we go with the equation. Y equals 0.0598 multiplied by x plus 0.9986 for our y formula. And this tells us that the coefficient of 0.0598 means that as the loudness variable increases by 1, the predicted value of energy increases by 0.0598 plus 0.9986. The R-squared value of 0.537 or 53.7% means that 53.7% of the variation in energy can be explained by using the loudness as the predictor variable. So that's pretty good. It's not great, but it's a good start for a predictor variable in my data set, especially because my numbers are all very, very low. It's kind of hard to get a good predictor variable going. So for my fourth question, for multiple linear regression, I just got an info of how many columns and rows I have so I can perform the regression itself. So I have 15 columns, and I printed it out here. So I do have some string variables that I needed to get rid of, obviously because that input cannot take string. So I eliminated name and artists from that so I could correctly perform the regression. And here I'm performing that. And I found that a lot of my p values are pretty high. You know, they're not really dependent on each other. And so I started like playing around and omitting some of them. And I found, here we go. I found that this was the best R value that I could find, 15% R squared, which is pretty low, but it is higher than what it was originally at, which is over here 14. So that was nice. For question 5, transform for the logistic regression model. I got a histogram going so I could see the bounds of my data of what I want to work with. I found that the best level was around here at the 0.65 mark. As you can see, the data fluctuates right over here pretty high, so that's why I chose that bound right there. So I started performing that, and I got to my arrays, which was a bunch of numbers, and then perform my logistic regression over here, and I found that it was actually 65% accurate, which once again it's not the best, but it was a well predictor of the energy variable that I had. So as seen above, the accuracy of the logistic regression model is 65%, which is moderately high. And the regression model isn't a great predictor, like I said, but the accuracy of the data isn't going to be high enough just because those numbers are very, very low and don't fluctuate a lot. As you can see over here, they're basically all from 0 to 1. That's my correlations. There we go. So it's kind of hard to create like concrete predictions with the data, but I think the linear regression model did work ultimately at the end.